But the biggest challenge for Google using PageRank is the challenge of scale. The N is too big. But fortunately, these graphs, H is sparse, and the other graphs matrices are rank 1 matrices. So you add two rank 1 matrices to a sparse graph, you get a very well-structured graph G that helps a lot in scaling up the computation. Notice that this computation is done in a central server. DPC is done in a distributed way. That's the word distributed power control. So there's a big contrast between those. But then again, in DPC, we're talking about tens of nodes. Here we're talking about millions of nodes relevant to a search, if not the entire set of web pages, 40 to 60 billion out there. There are quite a few tricks you can use to improve the scalability of this centralized computation. One is numerical linear algebra methods. Okay, there are a lot of ways to decompose this matrix H so that you speed up the computation of matrix multiplication. There are also a few more tricks. For example, it's only the order that matters, so don't worry too much about converging on the scale of the importance scores. Certain web pages can be grouped together. The dangling nodes can be treated separately, and you may also have a hierarchy. You can group certain clusters of nodes together and run an approximation before you're distributing a given importance score among those nodes in a cluster. In the homework problem, we look at this cluster-based hierarchy approximation. So whether it's a speed-up method or approximation tricks, there are many approaches to make this algorithm work so fast for a large N.